Hello everyone, welcome back to the channel. In today's video, we're diving deep into an essential CCNP switching lab, implementing a spanning tree protocol. This is our subject. We'll go step by step through default spanning tree behavior, configuring rapid spanning tree, and implementing key spanning tree toolkit features. Let's get started. Perfect. Here's the topology we'll be working with. We'll got two distribution layer switches, DLS1 and DLS2, and two access layer switches, ALS1 and ALS2. All devices are interconnected with redundant paths to test spanning tree behavior. First, we'll need to load the base configuration and configure trunking on all switches. So, for example, I open DLS1, enable interface range fast 0, 7 to 12, switch port trunk encapsulation.1q, switch port trunk native VLAN 666, switch port trunk allow VLAN except 1 to 999, and switch port mode trunk, switch port non-negotiate, and no shutdown. Perfect. We do this configuration to another switches. Then we consider DLS1 as a VTP mode server and VTP domain. We choose VTP domain SW lab. We want to use VTP version 3, so I type VTP version 3. Now we want to using show spanning tree routes, we find the DLS1 has the lowest bridge ID and is elected as the route by default. But in real networks, we want control over the route bridge elections. So we configure DLS1 as the primary route for VLANs 99, 999, and 100, and DLS2 as the primary route for the VLAN 110 and 120. We'll also set each as a secondary for the other VLANs for redundancy. So let's do this. If it's not what you want, set and secondary rules manually. We opened DLS1 again, enable configure terminal, spanning tree VLAN 999 and 100 as a root primary. Then we choose spanning tree VLAN 110 and 120 as a root secondary. Then we open DLS2 and do the same things but reverse. So I mean spanning tree VLAN 110 and 120 as a root primary on DLS2. After that, spanning tree VLAN 999 and 100 as a root secondary. Now let's enable rapid spanning tree to speed up coverage. We open DLS1 and type spanning tree mode rapid PVST protocol and do the same on all switches. Now rerun their test. You'll see convergence in under a second as a root secondary. Now let's talk about the spanning tree toolkit feature. First things is PortFast. PortFast allows edge ports to transition to forwarding state instantly. We enable it on the ALS1's Fast 6 where host A is connected. Without PortFast, the port sends proposals. With it, the port transition immediately. So we open ALS1, enable configure interface 6, switch port mode access, switch port access VLAN 120, spanning tree PortFast. This skips the 30 seconds delay, great for PC and printers. Now we want to talk about BDP Guard. BDP Guard shut down a port if it receives BDPUs unexpectedly. We enable it on ALS2 fast 11 and immediately see the port go into a disabled state when BDPU arrives. So we open ALS2 interface 11, then span 3 BDPU Guard enable. This is useful on access ports. It's trigger error disable if it detected BDPUs. Now let's talk about root guard. Root guard protects against unintended root takeover. We enable it on DLS1 fast Ethernet 8 when ALS1 is configured to take over as root. DLS1 blocks the port and flags it as a root inconsistent. So we open DLS1 interface fast Ethernet 8 span 3 guard root. If this port receives a superior BDPU, it goes into root inconsistent state. Now we want to talk about loop guard. Loop guard protects against unidirectional links issue. We enable it on ALS fast Ethernet 11. When we stop sending BDPUs from ALS1 side, loop guard kicks in and puts to the port into loop inconsistent state, prevents to a loop. So we open ALS2 interface 11, then span 3 guard loop. This protect again unidirectional links failure. And that's a full tour of implementing and optimizing a span 3 protocol in Cisco Layer 2 network. You now have the tools to prevent loops and improve convergence in your network. If you found this helpful, don't forget to like this video, subscribe to channel and drop any question in the comments. See you in the next video.